Alright, for today's lesson we're going to work on congruence, particularly with triangles. But first let's review what congruence means. So directions: read the following information about congruent figures. Congruence, equal, and reading diagrams. Equal is not always equal, but at least we know that it is. These are kind of weird concepts. They are very simple, but the weirdness is in the fact that they are almost the same, but not the same. Congruence. Saying that two figures are congruent is to say that they are the same size and shape, like these. This triangle is congruent to this triangle. This line segment is congruent to this line segment. This angle is congruent to this angle. Yes, these are the same size and shape. Remember, the segments aren't the angles. We're only looking at the angle measurements here. So I know this segment's a little bit longer than this one, but the angle size is the same size. If you want to say two segments are congruent, you do it like this. So remember, when you name segments, you name them with the letters and then the line above them to symbolize that it's a segment. So segment AB is congruent to segment CD. The symbol with the equal sign and the tilde above it means congruent, or is congruent to. So this reads, segment AB is congruent to segment CD. If you want to say two angles are congruent, you do it like this. Angle A is congruent to angle C. So again, the symbol with the equal and the little squiggly line above it means congruent, or is congruent to. So this reads, angle B, that should say angle A, typo. Angle A is congruent to angle C. Let me write that in with my black pen. So here's how you know two segments are the same length and congruent in a diagram. Every segment that has a slash mark on it is congruent to every other segment that has the same slash mark, called a slash or a hash mark. So in this diagram, the segment BE, from B to E, is congruent to the segment from D to E, so BE is also equal to DE too. Every segment that has two of them is congruent to every other with two. So AE is congruent to EC, but BE is not congruent to AE, so they have to have the matching symbols to be congruent. So AE is not congruent to BE because they do not have matching slash marks or hash marks. For angles, here's how you know that two angles are the same measure and congruent in a diagram. So in this one, you have the angle mark here. Only one arc. Here you have two arcs. So any angle with one arc is congruent to all the others with one arc, and any angle with two arcs is congruent to any angle with two arcs. So just looking at the arcs, you're able to tell if things are congruent or not. So we're going to do a little investigation with congruent shapes, particularly with triangles, and we're going to use some of our previous knowledge of terms that we've learned in the beginning of the school year. So given two triangles, ABC, and it's congruent to triangle DEF. We're going to identify the corresponding parts in the two triangles. Remember, corresponding means matching. So to determine the corresponding parts of the triangles, let's use patty paper to follow the steps to answer the questions. So using the patty paper, it says trace triangle ABC onto the patty paper. So I'm going to trace triangle ABC. Make sure to label the letters. Step 2 says to slide the patty paper over to triangle DEF. So remember, this is a translation. I'm just going to translate this triangle over DEF. So you can tell that they're congruent because they're matching up right on top of each other. So now we can match up the corresponding parts. So we're just going to match up which angles and sides match up with each other. So looking at it, angle A matches up with angle D. So if you flip your patty paper up, D is the angle that A is on top of. So angle A and angle D are the same size and shape, so they're congruent. Angle B matches up over here with angle E. So angle B and angle E are congruent. And then finally, angle C matches up with angle F. So just by knowing that two triangles are congruent, you can tell me that the three relationships between the angles that are congruent. Also, we can look at sides. So here it says AB. So AB was my bottom side. AB is matching up with DE. So AB and DE are congruent. The two segments are congruent. AC was my slanted side on the left. When I put it over here, AC matches up with DF. So AC is congruent to DF. And then finally, CA is actually the same thing as CAC, so change that into CB. It's another typo. CB matches up with F and E. So since all three angles and all three sides are the same, we say that triangle ABC is congruent to triangle DEF. And the way you name your triangle statement is particularly important because, if you look, the corresponding sides and corresponding angles can be identified by matching the corresponding vertices of the two triangles as shown below. So when I said angle A matches up with angle D, when I name it with the triangles, I make sure to name them in the same position. So A matches up with D. B matched up with E, and F matched up with C. Same thing with the sides. AB are my first two letters, DE are my first two letters. AC are my first and third, DF are my first and third. CB are my last two letters, and FE are my last two letters. So using the statement, we can also prove that triangles are congruent. Okay, let's try some other types of ways to prove triangles are congruent. Here we're going to use a reflection, so we're going to do the patty paper again. It says trace KMJ onto patty paper, so I'm going to trace KMJ. That's my triangle. I'm going to draw this line as well, just so I have my reflection. So we're going to confirm that the following triangles are congruent by reflecting triangle KMJ on top of triangle QRP, and then answer the questions that follow. So if I reflect this, remember reflecting means you flip it, so I'm flipping it over. You can see that these triangles are congruent because they have matching positions and there's the same size and same shape. So after I flipped it, I can now answer my questions on the bottom. Angle M corresponds to, well, taking a look, here's M. M and R are the matching positions. So angle M corresponds to angle R. Angle P corresponds with, based on my reflection, it's corresponding with J. So angle P corresponds with angle J. And the last one, angle Q, corresponds with, that's my K, angle K. So from reflecting it, I'm able to show that these shapes are congruent to each other. JK, here's JK. When I flip that over onto this side, JK matched up with PQ. RQ, that's this bottom part here, is matching up with KM. And PR is my side right here. When I reflected it, PR is matching up with JM. So these are the corresponding parts of the congruent triangles using reflection. The last way to prove that things are congruent using transformations is with rotations. So we're going to confirm that the following triangles are congruent by rotating. Remember, rotating means spinning. Triangle FGH onto triangle ABC, and then match the corresponding pieces for those triangles. So using your patty paper again, I'm going to use the same patty paper. I'll just use a corner that I didn't use. I'm saving paper. Tracing over FGH. and labeling my sides, F, G, and H. Remember, rotating means you spin it, so I need to spin F, G, H to fit on top of A, B, C. And when I spin it, now I can see the letters that are corresponding with each other. Here it's asking me to write down the statements. So here it says triangle FHG is congruent to what? So I have to match the same letters in the same order. So FHG is congruent with ACB, triangle ACB. You have to make sure you're matching the letters in the same position. BAC, if you look at BAC, that goes bottom this way. That matches up with GFH. HGF is from my top down my left-hand side. So that goes with triangle CBA. And now we have to do for triangle CAB. Looking at CAB, C is at the top, then I come down to the right, and then to the left. So CAB matches up with HFG, triangle HFG. So work on today's lesson, just practicing identifying corresponding and congruent parts of triangles.